different. I actually recently gave my class a challenge to code a decision tree from scratch. And you know what? Actually, I haven't done it before. But I thought it would be a cool exercise because I think that will be something interesting to learn how to use a machine learning algorithm and be able to implement it yourself rather than using a package. So before I begin, I'll just do it for the reduced problem of a binary variable. Okay, but it can be extended to more kinds of variables. Yep, if you just bin them in the right way. So firstly, just to start, this is the example code of how we do a decision tree. So we import some pandas tools for data frames. Uh, NumPy is for array manipulation. Okay, but with pandas, actually, maybe we don't need NumPy already because we can manipulate things as a data frame or data series. Then basically, I have stuff like matplotlib to plot graphs. And then over here, actually, we may not even need to use this. I just put this here first. sklearn import decision tree classifier. This is the decision tree classifier for sklearn. Let me just show you. sklearn decision tree. There we go. So with the sklearn decision tree classifier, you can actually use this to do a decision tree, and this is the function that we will try to code out ourselves. Okay, we need to do the splitting function, and then basically, if you look at the decision tree code, it is basically, let me go to the code at the top. Oh, they don't have a sample code. Yeah, something like this. You actually need to fit the tree. Okay, they didn't really put it here. Okay, but basically after you fit the tree, okay, you can then, so this creates the data. So you are predicting the y variables from A, B, and C, and you need to decide where to split on A, B, or C. And then like over here, this will be your x is your input variables, y is your output feature, and then we just basically fit the decision tree on x and y. So if we run this, okay, we will see that this is the decision tree. So initially there will be tree of 0 and tree of class 1, tree of class 0. And then firstly we split, okay, by the binary variable x2, which is variable c, and then we can get two of them. And then after that we split on variable b. Okay, so this split on c, split on b will lead to a clean split at the end where you have only one of each class, which is what we want to do. So let us see how we can implement this. Okay, how can implement this using our own decision tree classifier. So firstly, what we need to do is we probably need to create a class called decision tree classifier, or maybe we just call it my decision tree. Okay, because this is your own decision tree. So this class, we have an init function. So this init function will basically take in some values like max that equals to 2, and then actually it should take in stuff like criterion. Okay, but over here we just use the criterion for uh, information gain. Okay, which is basically find out what's the decrease in entropy of the parent to the children using this formula here, which measures how chaotic that node is. So basically, if this is a clean node, okay, then the entropy will be 0. Okay, uh, eventually we want all our nodes to reach entropy 0, and in order to make them clean, so that means the more uniform the distribution of classes are, the higher the entropy. So as long as once you split, we make the entropy lower, that is actually good for us. So we want to split at a node that has the highest information gain by maximizing this difference over here. So let us just put in one variable called max that, and then we can just call this here. So this will basically tell us how deep to split our decision tree to. Okay, then we should also have a function, okay, where we will define this as an entropy function. Okay, and the entropy function will take in the data. Okay, so what we'll do is we need to look through um, all. Okay, let's just try this out here. So we have this data x and y, right? So if we were to fit this x and y inside our decision tree, okay, maybe we should do the fit function first. Okay, then over here we will basically need to create. Okay, maybe over here we got split. Okay, so we need to create the splits. Okay, and then after that we will need to find out the best split, and then create. Okay, maybe we just do for one iteration of the split. Okay, because we actually need to recursively do it, but let's just do for one first. So this entropy here will basically tell us the entropy of our y value after we do the split. Okay, so after we do the split, we take the y value, and then we see what is the distribution of this y over here. Okay, so over here we can just take in like maybe we can have the entropy. Okay, the like y values here. Okay, so you just take the y. Okay, let's just try to figure out how to use this y dot value counts. We get 0 1 2. Oh, okay, so 0 0 0 1 1 1. Okay, what's y? Okay, y is this thing over here. Okay, maybe if I were to do it like that, let's see. If I were to just do it like this, let's do the y dot value counts again. There we go. Then we have two of them. So if we take the length of this, what do we get? We get 2. Okay, so very simple. So over here we have for each in. Yeah, so we can just do it like that. For okay, so we can just do like that. Count equals to x for x in value counts. So I mean, if we were to do this here, let's just do it here. Oh, okay. Let's just do it like that. Okay, we print out count, we get 3 3. So this will just tell us what is the number of the variables in each of this value counts here. Okay, so we have different things here. So if we have like more, let's say if we have like another y data like that. Okay, let's just, okay, if we do the decision tree, it will be slightly different now because we have 3 different classes. Okay, so oh, how come it's still the same? I think we need to reload this. So over here, yeah, there will be 3 different values now. Okay, but that's not a big deal. Okay, so what we can do is if we do value counts here, you can get 3 2 1, which is the total number of classes for that y itself. Okay, so we are only just going to do for 2 different classes, so let's just use this. Okay, let's do this. Okay, now that we have gotten this correct, then we need to calculate the entropy here. So the entropy is very simple. We just need to take this thing over here. So what we need to do is we need to do count divided equals to sum of counts. Okay, so what does this do? Okay, so over here we kind of need to make this a numpy array, okay, in order to do this operation so that we can do the division straight away like that. Okay, we cannot true divide. Okay, all right, so let us just take a look at what what is this. Empty dot sum count is this. Okay, so we are able to get this. So yeah, we can just make this like that, and then what we can do is we can then return the entropy. So what we will do is we will then do a term and maybe we just call it E. Okay, we basically need to do this thing here. Okay, so we just do, okay, uh, sum, okay, of this thing here, pi log pi, so that will be count, okay, times np dot log 2 counts, okay, plus an epsilon term, okay, because we want to make sure that you don't divide by zero. So over here we can add a self dot epsilon term here, okay, count plus np dot log 2 count plus self dot x. So this will be basically, okay, so actually this will be x plus x, okay. Actually we can just name this pi, I mean just to make it consistent, pi, okay, for pi in counts, okay, and then we can just return this minus sign. Okay, expected and indented block. Okay, okay, I think I need to put self over here in all these functions. Okay, define entropy, expected, indented. Maybe I need to return here. Okay, good. So let us just like do something like this. My CLF equals to my decision tree next step equals to 2. Okay, and then maybe we will just do like maybe CLF dot fit just for the sake of it. Okay, then CLF my CLF dot entropy. We just want to calculate the entropy of this Y. Okay, got multiple inputs for max step. Okay, so okay, so this one we want to make this max step. My decision tree max step equals to 2. So what does this mean? Init got multiple values for argument max step. Okay, uh, shouldn't be a problem actually. So let's see why this is not working. So I don't know. Is there, I need to put self over there? No, I cannot do self here. Okay, let's just try it again. My decision tree. Let's see whether I can do this. Self is not defined. Okay, so it turns out that there's an issue with the init function, I think. Yeah, with maybe we need to put a self in front. Yeah, so yeah, I think I need to put a self there in order to reference the tree itself. So maybe something like that. Okay, so we have an issue here. Cannot ucast through divide with casting rule same kind. Okay, so I should do. So this is the reason why programming. Okay, now we have the entropy already. So we can see that the entropy here is very, very, very close to 1, but it's not 1. Okay, it's because of this term here. So maybe we need to set a condition, okay, that we don't put this thing here. We want it to be 1, okay. So we should do something like that. If else 0, if pi equals to 0, then we don't need this epsilon here. We just basically hard code, because log 2 0, if we do log 2 0, we will get a error. Okay, negative infinity. Actually, they still allow for negative infinity, so maybe not a number. Yeah, so we have to do this. So we have to do this like that. Else, Yeah, so in the case that it's all zeros, okay, we will basically make sure that, yeah, we will basically make sure that it becomes a zip. If let's say this is zero, if this is not zero, we can do this. Okay, otherwise we'll do this. So if pi greater than zero, yeah, then we do that. So we can see, okay, so you can see that y itself is like that. Okay, so y is okay, why I believe this is this is a data series, if I'm not wrong. Okay, so let's say if I want to create a new data frame like that, so we could do like y equals to pd dot data frame. Maybe we can do like maybe all ones. Okay, let's print out what's y is like that. Okay, then maybe we can do like the same function that we did earlier. So y equals to this, so this is zero. So if let's say I were to do like 1010, this will be like that. 101, 0.918. So I think the entropy function is more or less defined already. So we can calculate the entropy like that. Okay, let's remove all this. Okay, let's go back to the normal y. Okay, so we already did this. Now what we can do is we should find out the best split. Okay, in order to split x and y properly, we need to find out the best split. So what we can do is, okay, so so in this case, the decision tree is all binary variables. We should just split based on the binary variables. So maybe we can just put like a number of variables that we want to split. So this is a bit hard coding. Okay, you can actually do this to customize to the data by just observing the length of the columns. Okay, but for now we just do like num variables like that, and then maybe over here this will be just a split order. So it's basically, okay, we just do for one split first. Okay, to make things simple. So what we will do is like this. So for this split function, okay, what I will do first, okay, is to just loop through. Okay, so maybe we just call it best gain equals to zero. Okay, and then maybe the best split equals to this thing, because we need to find out what is the variable that we want to split on. So maybe over here, since I already know that this is ABC, okay, I can actually um, easily get this number. Okay, maybe we should make this num variables here. Okay, so self dot num variables equals to x dot column. Okay, so let's just see what x dot column gives us. X dot column should give us A, B, C. So yeah, so x dot columns is a good way to say what are the variables to split by, because these are the index of my columns. Okay, so let's just see how do we do the best split. So we just look through for all the variables in each of these columns for variable in, okay, because now we are just doing a very simple case. Okay, if we are just doing binary variables, if we are doing something that requires continuous variables, you need to sort of bin the variables into equal bins. So you can just use the max and the min of that particular series and do it. But let's say we just do it for a very simple case of binary variables. Let's see how we do it. So for variable in this one, in fact, we can just call this num variables. So maybe I should make this like a list so that I can drop it easily. So let's see what happens if I do this to be a list. Yeah, this is better because then I can like do this like dot remove like that, and then we can like see what's going on. So let's say if I Oh, okay. Okay, so let's see. Drop elements from list. I think it's dot pop. Is it remove? That's the way to do it. Yeah, I think you can do it by remove. Yeah, you can just do it like that. By rights, you can do it like that. So c dot pop. Okay, so I got the issue. Okay, c dot remove. So because the remove operator will return a none, so you can do it something like this. So we can basically for each variable in num variables, it's not this is not num variables anymore. We can just call it variables. For variables in variables, okay, we find the best split so far. Okay, so maybe what we'll do is okay, let's just do it one for one case. Okay, we'll do the recursion later, but right now we just split on only one. So we have these variables in these columns. We have the best gain, best split. Okay, then we will need to do this entropy function to find out what's the best split. So what we will do now is, okay, we will just look through. We just look through the best gain. So let's okay. So we will look through and split on this variable. So if let's say I were to do like for variable in x dot in list x dot columns print variable. Okay, so what we can do is we can print okay x. So we need to basically group by a certain variable. So like variable. Okay, so we need to do something like that. There we go. X variable equals 0. So you can see that we have a certain list over here where it's either true or false based on whether or not. So we can group by this thing here. So basically this x variable equals 0 will give us the columns to be removed. So you can just keep like child a equals to variable yeah, you can split like that. So what we can do is we can print out child a, print out child b. We can just print out like that x child a, x child b. So this will tell us like if we split by that variable, what will we get? So if we split by the variable, we get this field here, this field here, this field here, and so on. Okay, we can even do this for the y's also. So we can do it like that. Child a is this, child b is this, and then like we could also do like for the x itself. So maybe what we can do is instead of having the information gain here, actually we just need to find out the lowest average entropy because the parent itself will always have the same entropy. So we just need to have the lowest child entropy over here. So take lowest, and we just want to find out the lowest entropy because this will increase our information gain. We don't need the entropy of the parent. Okay, because as long as your children has the lowest entropy, that's good enough. The parent entropy is always going to be the same. So what we can do is like that. We can have ya. So we need to find out how many values this variable has. So maybe what we can do is, okay, so we can actually find out equals to length of, okay, x bar dot value counts. Okay, so we can split by that value. Okay, so based on this num value, okay, based on this num values, okay, we can then find out, uh, so this is basically like for the value in num values, we just find out, okay, this one is greater than, so we have a child A that will be smaller than this value, maybe like this, yeah. So over here we have two values, 0 and 1, so the split will be like that. Smaller equals to value, greater than value. As the num values itself would actually be 2. So, but actually I shouldn't do this. I should do the unique values. 0 and 1. Yeah, so we should do the unique values here. So based on the number of unique values here, okay, because actually I already know that it's going to be 0 and 1 here, but over here, if let's say there's many different unique values, okay, we need to sort of like uh, find out which value to split on. So we have this over here. So for value, maybe we just call this unique values or value in unique values. Okay, we find out whether this one is it. Um, yeah, we basically do a split. Okay, okay, so we basically split child A and child B like that, and yeah, we also do the same thing for the Y's as well. Okay, so we have this for a single split, all right, and then what we'll do is we'll just calculate the entropy. Okay, this calculate the best split will be earlier. Best variable to split on and the value. Okay, then after that, what we will do is we will then find out entropy of the children. So we need to find out the entropy by taking the, yeah, I just wonder if I were to do like length of x, what will I get? Yeah, that's 6. Okay, so we can find out the entropy of the children by doing this. So we just like self dot entropy ya. Okay, what we'll do is like that. So self dot entropy ya plus self dot entropy yb, and then we need to find out the length of this. Length of a minus length of y times this plus length of yb divided by length of y times this, because this will tell us the proportion. Then we get this. Okay, and then what we'll do is, if this is the best, add to the best split. So what we will do is if average entropy is lower than the best than the lowest entropy, well, let's just call it best entropy, and we just make this like maybe a very large number. Okay, best split equals to this variable, and then the best unique value will be equals to this value here. So then what we will do at the end is we'll add the best parameters to the split. So what we do is self.split, okay, equals to, okay, we just do for one first, later I'll come back and do the rest. Okay, so let's just try to see whether this works. So we have a decision tree classifier roughly, okay, like that. We feed in x and y, and then we basically just print out the best split at the end. Okay, unique value is not defined. Okay, let's see. So this actually should be value, not unique value. My decision has no, oh, it's got split, not best split. Okay, so it splits by A with value 0. So let's also just print out, okay, the best unique entropy is 0.918, and it splits by A. So if we take a look at the this decision tree, you can see that it splits by C. Okay, C is fine also, okay, because actually the entropy is also 0.918. Okay, so this means that this way of doing the decision tree, we have managed to split by an optimal value. Okay, so right now what we'll need to do next in the next stream I'll be doing is, let me just put here, to do loop recurse this till max depth. Okay, and then also we should do another function called predict. And we will do this. Okay, to do predict the label for unseen data. Okay, we need to do that as well. Okay, so we need to do a recursion here. Okay, so this unique thing is not exactly that great. Okay, we can actually take the unique values, okay, and then we can just bin these unique values into a few bins. Okay, maybe we can put here as num bins equals to what. Okay, then we can actually make this more robust. We can do continuous values as well. Okay, so that will be our future work. So maybe let's just to do, let's put another to do here. Make this work for continuous variables. Yeah, I think that's great for our first stream of the decision tree. And yep, I'll be back to code the rest of it. Okay, to code the recursion part. And yeah, see ya.